start from the next problem, which is problem number 4. Okay, so the problem number 4 says two groups consisting of 108 and 156 students participate in sports meet. In how many rooms can all these students be accommodated at the minimum if all the rooms should have equal number of students and no two students in a room should from different groups. Let's read it out again. Two groups consisting of this and this number of students participated in sports meet. In how many rooms can all these students be accommodated at the minimum? That means you have to accommodate number of students maximum or in every room. The condition is that you have to use the minimum room. So in that case, one thing is that you have to put maximum students in there, but the limitation is that no two students in the room should be from different group. That means in a room there should be a maximum number of students, but that has to be a purely of each group. No two group will be combined together inside any room. So that is the condition. So in that case, the first thing is that when you are supposed to get maximum student in the room, so your consideration should be these two has to be factored in such a way that you will get the highest common factor, because this is common I am saying, because the number which has to be accommodated maximum will be implies to this group, even though they are not mixing, but they both have a task to meet the maximum number of students in a group. So if you consider both together, then that only the thing will come out where you will get the maximum number of students by taking the highest common factor of these two. The first task is to find the, so I will rub it out. I think you have read it out, so I will rub some of the portions so that I get some space here. So I will do what I will do. I will find HCF of these two. So I will do it with a divisional method, starting with the minimum prime, that is equal to, that is 2. Now 7, 8, again with the 2, 27, 39, now with the 3, 9, 13. So thereafter it won't go. If it would be a LCM, then I might have continued till I get 1 at the bottom. But it is HCF. For HCF, till I get the prime number, any prime number which cannot be a common divisor, means I will not get any common divisor, till then I have to continue. For HCF, remember, I have to continue till I get a common divisor of these two. But in LCM is nothing like that. Till you get 1, 1, 1 at the bottom, you continue. Even if it is a divisor of 1 or 2 or many, you won't mind. You go on doing that. But HCF, you have to do till you get a common divisor. So here, the 9 and 13, there is no common divisor. So I will stop here, and I will consider these 3 number as a HCF. Means these 3 with the combination of, if I multiply these 3, I will get HCF of these 2 numbers. So the HCF will become 2 to the 4, 12. So each room should have 12 members. Now, what would be the number of rooms then? So if I consider individually, so this, if it is the highest common factor, so 12 in a room, to divide 108, I have to have this many rooms, because I cannot mix, and for this I have to have this many rooms. So individually, if they are kept and not mixed, so minimum this number of room is needed to accommodate this, and for this 13. So altogether the minimum number has to be 13 plus 9, that is equal to 22. Okay. So next comes the sum number 5. So sum number 5 says which of the following number is divisible by 3 but not 9. So numbers given are, first number is 7983, second number 14301, third one is 1668, and fourth one is 4995. Okay. Now we have to, if it is a multiple choice, then first thing is that you have to remove the numbers. You have to try to remove the numbers which will not at all a participant for this question, because there you can see which of the following numbers is divisible by 3 but not by 9. It is a specific condition, but if in case I consider 3 and 9 as a divisor, then which are the numbers which not at all a participant? this you can see is not definitely not a participant, because the last number is 5. Okay, or else not like that, I cannot say it like that. Okay, so leave it like that, because that may be a divisible by 3, because not only 5 is divisible when there is a 5 at the last number. So leave it like that. So my concept is that when it is divisible by 3, the theorem says if we add all digits, and if it is divisible by 3, then the number is divisible by 3. To simplify the length of the calculation, unless or otherwise you can straightway go and divide all these numbers and it will be a big process altogether. But instead that, if you remember the short concept that I have taught you, any number is divisible by 3 if I add all the digits, and if it is divisible by 3, then the number is divisible by 3, and that the same implies for 9 also. If the number is if I adding with all the digits, if it is divisible by 9, then it is divisible. So start with this. Now first, because this has a very common calculation, you have to add the digits, then after you can see yourself directly whichever is divisible by 3 or 9. Okay, so if I add this, 7 plus 9 is 16, 16 plus 8 is 24, 24 plus 3 is 27. It is divisible by 9 and 3 both. Okay, 9 and 3. So the question is, which is not following number which is not divisible, it is divisible by 3 but not. So this could not be the answer. Now come here, 1 plus 4 5 plus 3 8 plus 1 9. It also cannot be, because they are divisible by both 3 and 9. Let come here, 1 plus 6 7, 7 plus 6 13 plus 8 21. Is it divisible by 9? So this is not the number which is divisible by 9, although it is divisible by 3. Now come here, let's try it. 9 and plus 4 13, 13 plus 9 22 plus 5 27. So this is again divisible by 3 and 9. So this cannot be the option. So the only option remains is that one. So initially I thought that is only 5 is remaining, so maybe it is divisible by 5 only. But the thing may not be like that. It may be divisible, as you see, it's divisible by 3 and 9. So by that theory you can eliminate the number. So if you know that this is a theorem where adding the digits and trying it with 3 will confirm whether the number is divisible by 3. The same is applying for 9 also. Okay, so next comes your number 6. Number 6, in an or this you know, leave it and switch to the next number, next sum. In a walking competition, in a walking competition, 3 persons step off. 3 persons step off together. Step off together. Their steps measure 85, 90 and 80, 90 and 80 in centimeters, okay, respectively. What distance from the starting point will they again step off together? So this is your question, where three person taken a part in a walking competition where they step off together. That means their starting line is same. 3 person, 1, 2, 3. They are starting at same point of time. That means in a starting point they are starting, and they have a step length of different step length. So one started with the 85, one step there is a little bit higher in the second, and third is little bit lesser than the all these two. So they are, let's say they are moving with the same galloping length every time. So there may be some possibilities that they will meet at some point, let's say. So you have to find at what distance from the starting point D they will again step off together. Okay, so this may happen that the question may arise in your mind that if it is a higher step he is taking, he will reach somewhere fast, somewhere earlier. But thing is that their speed can be different, because to match with, if they are said to be met at some point in between the finish in between the finish lines and starting line, their speed may vary. So there is no thing being explained or said in the questions their speed, about their speed. So you cannot assume that their speed is the higher step taking person is having the higher speed. So speed may vary and they match together at some point. So that doubt may arise, but I'm clarifying because it's not given. So you have to understood that as they are meeting, you have to take that consideration. As they are meeting, their speed is such adjusted, they will meet together. Okay, some point of time in between the finish and the starting line. So the question, how will you solve it? So as they are meeting some point, so that means sum of the number which is a common multiplier, because they are starting at the 0 point, or there is a starting point. So 0 is always a common point for everything, and after that there should be some multiple of this three number, which will be again a common number for all three. So in this case, as it is a common multiplier, so it must be an LCM for this number. So what I have to do, you have to understand or bring that concept in your mind, then the problem will be very easy. Once you understand what to do, then the calculation part is very easy, and you can finish it up in no time. So as because you have to find some multiple which is a common multiple of this three, where these three number will match, so definitely it has to be a common LCM, that means lowest common multiplier. Okay, so as you can see, all are having 5 or 0, so I can start directly with 5 without wasting, because the thing is that you will find it the same if I start with the lowest number also. So better to do to save the time. So 5, 17, 5, 18, 5, 16. So you can see after that there is no as because it LCM, so I have to try with the other number too. to 17, 9, 8. So again this is 17, 9, 9, 8 to 17, 9, 4 to 17, 9, 2. Let me do with some space, it is bit clumsy. Let me do it from the initial point. I will start with 2 prime number, which it will save my time also. 45, 40, because at the end 2 is coming, so better to start with the 2. There is no harm of starting with 2. 45, then 20, then 2, 85, 45, then 2, 85, 45 with 5. Then after, if I try with 3 will not help you, so better to start with 5, 5, 9, 5, 1, and then 17, 1, 9, 1, then 3, 1, 3, 1, and 3, 1, 1, 1. So what I got, 2 power 4 into 5 into 17 into 3 square. So if I calculate this, I will get the next junction where these 3 people will meet together. It will be in centimeter, you can convert it in meter. So I am not going to the calculation, it unnecessarily will kill my time. So this is for today. In the next video I will come with more number of problem for you to solve. Thank you.